Alright, so we are just going to do probably example 5 and example 6 together and finish filling out these strategies. And then the type 4 problems, I'm going to set that aside for tomorrow. And we'll do those tomorrow and then have some practice on type 4s tomorrow. As a reminder of what L2 kind of talked through in the beginning, we've talked about how a limit can exist when there is a hole in the graph and when there is no hole, because it doesn't matter what's happening at that point, just happening as you get close to that point. So we looked at a horizontal line, and we thought there's a limit because the y values from both sides are approaching 4. Then here with this line, we could see that as x got closer to 5, your y values were getting closer to the height of 5 as well. And then I think we did this here, but then we talked about the fact that if the limit here was 14, you could also get that number of 14 by plugging that focal point or that c value in for x. You got 14. So for most functions, especially if they're polynomials, direct substitution works to find the limit. So what did I say to try for every limit problem that you have to solve algebraically, not just with a graph or a table? What should be the first thing that you try all the time?
Substitute.
Try to directly substitute, because if it works, that's great, and you don't have to do a bunch of other stuff. You just plug a number in. But there are functions like exponentials, logarithms, square roots, trig functions, piecewise, rational, and there's some others that are on that list that are not continuous. So it's not guaranteed that when you plug it in, it's going to give you an answer out. If you plug something in and you get 0 over 0, so if you get what we call an indeterminate form, or you get something where the denominator equals 0, that's when you have to try some of these other strategies to try to work it out so that the problem, or what's making it 0 on the bottom, cancels out or disappears or something so that you can directly substitute. So we looked at several examples. Let me zoom out again. Looked at 2 examples here where you had a rational function, which just means it's a fraction with x in the denominator. But direct substitution works, so we didn't have to do anything fancy. And same thing here. Then we looked at some trig functions. And cosine and sine, those are trig functions that are continuous. So it did work out when we directly substituted something in. You ended up getting a nice value. You didn't have to do anything crazy. And then the one strategy that we talked about was in this example where when we tried to directly substitute, you ended up getting 0 over 0. If that happens, you cross it out, and then you try another strategy. So since I had a quadratic on the top and a quadratic on the bottom, I've tried factoring. And when we factor the top and factor the bottom, something canceled. And if something cancels, or you can rewrite it in a different way, then try directly substituting again, which we did here, and we ended up able to get an answer. And we talked about the fact also that because we were able to cancel out that x minus 4, in the original graph, that would have been a hole in the graph. If you can't cancel it out, like we couldn't cancel out this x plus 2, so that means on the graph, if we were to graph it, it would be an asymptote, because we wouldn't have a limit right there. Okay? So I think the first thing we wrote down was that factoring and dividing was one strategy, and it's pretty clear when you can use that because you usually have a quadratic or a cubic on the top and something that you can factor on the bottom. So the next type of problem we're going to look at is this one. So we're going to look at the limit as x approaches 0 of this rational function. So it's the square root of x plus 1, and you're subtracting 1, it's all being divided by x. So again, just because I want you to get used to doing this, we're going to try directly substituting in. But if I directly substitute in, what do you see will happen on the bottom? It's going to be 0. So, and I even think I would get 0 on the top. Okay, so direct substitution, if you try it, it doesn't work. So that means there has to be some other strategy. If I have to solve this limit or find this limit algebraically, I think the word that they use in the textbook is analytically, it means the same thing, then there has to be some other strategy we can use to make this look different and manipulate it so it looks a little bit different. In this case, when you have an x on the bottom like this, one way that we can manipulate it, and a pretty common strategy, is to multiply by the conjugate. Now normally we multiply by the conjugate of the bottom, but the bottom doesn't have a conjugate because it's just one term. So now we're going to multiply by the conjugate of the top. Now, technically, am I changing the problem? Because what am I technically multiplying by? I'm multiplying by a fancy form of 1. So this is just a manipulation thing to make it look different and hopefully allow me to plug something in. Now, across the top, I'm going to need to FOIL. This square root of x plus 1, it's like one term. Okay? So let's say it was, just so that we know what we get when we multiply these together, let's say it was just square root of x. What is square root of x times square root of x? Because it would be the square root of x squared, right? And then you would cancel them out, you just get x. So when you multiply these together, square root of x plus 1 times square root of x plus 1, it would be the square root of x plus 1 squared, or just x plus 1. So multiplying these together just basically cancels out the square root and leaves you with x plus 1. Okay, because I need to FOIL because these are technically two binomials. So that's my first term. My outer term is positive square root of x plus 1, but what's my inner term? Negative. So the outer and the inner are going to cancel. That will happen because you're multiplying by the conjugate, which is nice. And then negative 1 times 1 gives me negative 1. Now on the bottom, we need to multiply these together, but don't worry about distributing it through. Just leave the x outside and then group the other denominator. We're just showing that we're multiplying x and that denominator together. On the top, what happens? 1's cancel, and you're left with x over x times square root of x plus 1 plus 1. Now, does anybody see anything? The x's cancel because these are being multiplied together. I can cancel those out. Now, do I have 1 or 0 on the top? I just have 1, right? Because x over x is technically 1. So we have 1 over the square root of x plus 1 plus 1. Okay, so I've simplified. I've used some technique or some strategy here to make this look different. Does this look different than what I started with? Yes. So once you use a strategy to simplify it or whatever you can do to it, then try directly substituting again. What was the c value that I'm trying to plug in? 0. So now if I plug in 0 for x, am I okay? Yes. Because I get 1 over, well, the square root of 0 plus 1 is just the square root of 1. The square root of 1 is just 1, and so I'd get 1 plus 1 on the bottom, or 1/2. So 1/2 is my limit. And then you'd have to write your limit statement. So the limit as x approaches 0, I'm just going to write f of x equals 1/2. All right. Now flipping the page, we're going to add that to my strategies here. So factor and divide, cancel out like factors, then try direct substitution again. The second strategy that you can use is to multiply by the conjugate of the numerator. And after you simplify, then try direct substitution again. Okay. All right. And then the last strategy, we'll do an example 6. We're going to find the limit as x approaches 0 of 1 over x plus 4 minus 1/4 all over x. Okay, now right away we can see if we plug in 0, we're going to have an issue because you have x on the bottom. So direct substitution does not work here. When you have a situation where you have fractions on top of fractions, because could I make x a fraction? Yeah, by putting it over 1, right? You're going to need to use this strategy. Now this strategy is one that we've used before because all this is we're trying to get like one fraction over one fraction so I can flip and multiply. I have two fractions on the top. In order to add or subtract fractions together, I need common what? Denominators. So that means over here, I'm going to have to multiply by a fancy form of 1. That fancy form of 1 needs to be x plus 4 over x plus 4. And then, I have to identify, this x plus 4 is glued together. So it's not, you can't just multiply by an x over here because then you get 4x on the bottom. Well, 4x is not the same as x plus 4. So this is a unit, or a factor, you have to multiply by. And then we need another 4 in that denominator in order to make them common, the same. Alright, so I'm just going to simplify what I have. 4 times 1 is 4. And on the bottom, I'm going to keep it 4 times x plus 4. And then over here, what's my numerator in this second fraction? It's x plus 4. Good. 1 times x plus 4. On the bottom, 4 times x plus 4. You don't want to cancel the 4's out because if you do, then they're not common. Like you introduced it, so you want to keep it until we're done adding my fractions together.
Or is that x plus 4 unit, so they're one on the left on the top? Like, you know what I mean? So you can
Oh, yeah, in the next step we will. Yeah. Okay, so now we're going to subtract these fractions. Now they have common denominators. When you subtract, you have to be careful with these because you're not only subtracting x, but you're subtracting 4. You're subtracting both things on the top. So because we're subtracting x and subtracting 4, the 4's are going to disappear. And you're just left with negative x over 4 times x plus 4. And then over that fraction on the bottom that we already had. Okay, so now we have our goal, which was 1 fraction divided by 1 fraction. So now I'm going to flip and multiply that fraction on the bottom. So just take that x over 1 and then flip it. So now it cancels, or cross cancels, the x's. Okay, and I'm left with negative 1 over 4 times x plus 4. Now, that's about as simplified as I can get. This looks very different than what I started with. So this is like the simplified version of this. Because I technically didn't change this problem, I just manipulated it by introducing fancy forms of 1. Okay? So now when you get to this point, what do? Yeah, try direct substitution again. And what am I plugging in? 0. The 0. You're plugging in the c value from the original. So if I plug in 0, I get negative 1 over 4 times 0 plus 4, which ends up being negative 1 over 16. So because I didn't get 0 on the bottom, I'm okay, and I can say that that is the value of my limit. And then I would write the limit as x approaches 0 of f of x is negative 1 over 16. Okay. Alright. So if we're going to write that as a strategy, I guess we'll write it like this. When you have fractions over fractions, get your common denominators. Then flip and multiply. So when you get fractions over fractions, get common denominators, flip and multiply. And then after we flipped and multiply, what was the last thing we did? What did you say? Yeah, directly substitute. So then directly substitute. Now, these are the main strategies that you would use to find something, to find a limit algebraically, if you're told to do so. And they'll say, like, find the value of this limit algebraically, or they'll say find the value of this limit analytically. They mean the same thing. So you would go through this process. Now, let's say you're just told to find the limit, and it doesn't direct you to, and you try some of these things, but nothing is working. Then your last result, or your last recourse of action, I guess, is to go back and try to use a table or a graph. So if all else fails, graph and use the table to estimate the limit. If all else fails. Now, I will say, if it tells you to find it algebraically or analytically, you better not be using a graph or a table every time. Because if I tell you you can do it, then you can. And so you'll have to work it out. But if this is just like on the AP exam or on the test and I don't give you directions on it, then you can use a graph and a table if needed. But a lot of times you have to estimate and you have to round, so it's not as exact as they'd like. Okay. Yes, I think that's where we're going to stop in the notes today. We'll do the type 4 problems tomorrow. If you would go grab a whiteboard, a marker, and a rag.